Okay, so now I would like to walk you through the steps that I typically take to generate a solid polysurface site from a series of topo lines, typically provided with the site plan. So to start with, we'll just look at what we have, right? This is typical site plan. It's completely flat. Sometimes your site plan file may have topos that are already at the correct elevations, but in this case, everything in the drawing is at 0, right? It's actually just a flat drawing. So first step is just to get this to a point where we have the information we want and turn off everything we don't. So I'm going to turn off all of the hatches and the annotation for the moment, the trail lines. So we're just left with the topography and the site boundary. Okay. So the first step is to figure out the spacing or the distance, the elevation drop between each topography line. And we can turn our annotation back on because it does have an important bit of information here. You can see each of the lines is labeled, and this first line is actually the shoreline. So while we may end up using this, it's not technically one of the topography lines. So our increment, our step increment will be 5 feet. And we know that this first line here is at 0, and then it moves up from there. So we'll go ahead and turn that off again. So the first thing I want to do in modeling this is start moving each line to its correct position. So this line was the 5-foot point. So I'll go ahead and raise this up 5 feet. And I'll just move through each of these in turn. Okay. So I like to use the gumball and the widget here. You can just left click on the arrow and then key in the dimension. See, we're slowly stepping up. We're up to 25 feet. We're up to 30 feet. And then you'll notice these next series of lines are actually grouped. I like to do that with, in some cases, especially when you get into more complex topographies, there are cases where one level may have, half a dozen lines fragmented throughout the site that they're all at the same level. So you want to group them to just kind of keep track, to stay organized. Otherwise, this is a relatively simple site, but in some cases you could start to lose track of where things should be. So I just group these. Let's see, 40 feet, 45. And then a few more on this side. And the last one is at 60 feet. Okay. So now you can see that we've set each of the topos to their correct height. That is an important step in this process. Now, from here, the next step is actually to extract points from each of the lines. And I'll explain why in a second. But let's go ahead and select everything. And I'm actually also going to select the shoreline. I don't know that that's critical for this, but I think for this model, I'd like to do it. So you select everything, and then you can type in ExtractPt or extract point. And it will do just that. It will pull out a series of points from all of the curves. And just to kind of keep things well organized, I'm going to create a new layer. It's called, we'll call it Topo Point Cloud. And they're already selected, so I'm just going to type in now change layer and set all of these points to the point cloud layer. That's just a way kind of more easily manage this, right? Toggle it on and off. But going forward, we need these points. Okay, so we'll turn off the topo lines and we'll keep these series of points selected. All right, now let's go ahead and select them again. And the next step is to run the patch command. And so essentially what patch does is create a surface through a series of curves or points. If you use curves, like if we were to use curves in this case, the nature of the surface would be different, right? You would register each of those lines in the finished surface. It would almost be rippled. And I find that if you first extract points and generate the surface from a point cloud instead, it's a smoother, more accurate site surface. So within the patch command, there's some variables that we can look at. Most of these can be set to default. The sample point spacing 1 is fine. The stiffness is 1. The higher you go, the flatter the surface becomes. So if you keep it to 1 or less, it usually gives you a very clear, again, an accurate rendition of the site. And then in the middle, the surface spans in the U and V directions. I think the default is 10. I like to up that between 30 and 50 usually, but you can play around with different numbers. We have it set to automatic trim. I don't think that always works super well. And in this case, it probably won't trim the surface, but we're going to do that manually afterwards. So we can go ahead and turn that off. And we don't need a starting surface. There's no reference surface. Okay, so I like to use preview just to get an idea what we're going to be getting. And you can see, there we go, right? And at every point, right, the surface is pretty cleanly passing through our point cloud. All right. So that's the big step. Okay, so everything looks good. I'm going to go ahead and hit OK. That's our basic surface, but we can do more with this, right? Especially if it's going to be a useful tool for exploring different site options. And for example, if we want this to be a solid polysurface so that we can use the full suite of Boolean operations, we have to first create the solid, right? At this point, it's just a sheet, it's just a single surface. So I'm going to start, let's go ahead and turn off the points for the moment and see what we have. We do have the site boundary. So first thing I want to do is trim this to our site, okay? So I'll just type in trim, and it's looking for a cutting object. I'll use that. Boundary is our cutting object. I'll hit enter and then select the object to trim. Then I'll select the outer edge of the site surface. Okay, so that's a big step. Now we actually have something more clear to work with. It's the site itself. But we still don't have a volume. So a few things we can do here. One, where the lake bed, or not the lake bed rather, but the surface of the lake out here, if we were to build a physical model of this, that would be paper thin. So let's go ahead and copy, and I'll just use my gumball widget. And if you hold Alt, if you guys don't know this, if you hold Alt and then left click on the arrow, you can key in a distance. And by holding Alt, it copies whatever you're trying to make. So we'll do -20 feet. So it'll copy this outline down, right? So that gives us some depth below the lake. The next thing I want to do is better define the edge of the lake here, right? Because we have our topo lines still, right? That include the lake edge. But I think we want to call this out as completely flat. It's a lake after all. And if you look very closely at the surface that was generated, it actually has a slight arc to it. It's just the nature of the patch command. So I think we want to trim this out and get it to be completely flat. So we do have this already intersecting with what was our zero plane. So if we select that site outline, we can quickly make planar, out of planar curves. We can turn this into a surface. And then I want to see the intersection between the site surface and that surface that I just created. So not to get confused with our topo lines, let's go ahead and turn those off. And then just type in intersect, okay, and select our two surfaces and hit enter. And then it provides two curves, right? Because actually these two surfaces intersect at two different points. So, but that will be useful for trimming a surface out. So now if I want to trim this surface away, you can just type in trim. The cutting object is that intersecting line that I just generated. I hit enter. Now what do I want to trim? I want to trim the patch surface. So go ahead and select that. And there we go. On the flip side, we still have this underneath the surface, and there's some overlap here. So second step is to trim again using that same curve. Let's see if I can get it. There, it's still there. So I'm going to trim, select that as the cutting object, that same curve, hit enter, and then I'm going to select underneath here because I want to trim this part of the surface away. Okay, there we go. Now we have two surfaces that make this up, but now the surface of the lake is completely flat. I think that's just a nice detail. It gives us a clearer reading of what we're dealing with. And that other intersecting line, just delete. Okay, so this is coming along. Now that we've set these two to be our sort of defining top edge, I can go ahead and delete the original site boundary for the moment. You could also hide it. In fact, if we want to, we could just turn it off. But I want to keep this down here, so we'll keep it on for the moment. Okay, so to finish this out, we still need our enclosed series of faces, right? Anytime you create a solid, it has to be made up of a series of surfaces. If you want to work that way, you could build up a box or any volume through a series of surfaces that are closed and watertight. And then if you join them, it moves, it changes its state into the solid. So let's do that. And I like to start by building out the corners and really thinking in terms of kind of like a wireframe model. And sometimes you'll get situations like this where there's two lines that are really close together. And this is where you really want to pay attention, and craft matters. We don't want to snap to the top curve. You want to snap to that bottom curve. So maybe just for clarity's sake, I'll hide that curve so that we know what we're snapping to and there's not any clutter there. Okay. Same thing back here. Kind of the outline of what we're dealing with. And now the last step is really just to generate these surfaces. And you can create a surface through any number of ways. We're going to be using planar curves. We want these curves to be planar to one another. If they're not, there are other options, but I find that if the series of curves are expected to be planar in your file and they're not, it will give you headaches down the road to the point where you may have to remodel everything anyway. So we're going to use planar curves, and then we are hopeful Actually, I'm going to first explode this, right? Like this was a closed curve that was, you know, made up of 4 segments. I exploded it, so now I can select one of them individually. Okay, let's go back into surface, planar curves. Then let's select these curves, right? There we go. And if it is planar, it will create the surface. So it's that simple. We'll just repeat this process for each of the faces. Okay, 1, 2, 3, and again, pay attention to the details, because where the lake stops and the terrain begins, there's a little segment. So you want to include that to make sure that you pick up everything. Okay. Now, I'm going to leave the bottom free for the moment, because we can use the cap command, or you can build that surface out too. It's up to you. Now, if we go into, well, if I just pre-select one of them, it's a trimmed surface. It's a trimmed surface. They're all trimmed surfaces. They're not certainly joined. They're not solid. So we want to just pre-select everything. Okay. There we go. And then I'm going to just type join. And they should be joined together into a single open polysurface, because the bottom is still open. Usually, you can go ahead and pre-select any object that has an open face, as long as that is a planar open face, and type in cap, and it should instantly cap the surface off, right? Cap the volume off. And in the process, if I select this again, the object type is now reading as a closed solid polysurface. Okay, so that's the goal, right? Now we can use all of our Boolean operations on this. It is, I believe, a much more useful model, because you can always explode it to go back to surfaces, right? It's much harder to go from surfaces that have been manipulated and somehow kind of worked to a usable solid model than if you start with a solid model, right? So, but I think that does it. So one last thing that I did want to touch on. So we still have these trails. These could be seen as an important part of the project, right? There's one of my trails, which is almost on the surface to begin with. I'm going to just switch over to wireframe and find the other one. So here are our 2 trails. So it would be useful if we could get both of these trails onto the surface of the site. And it just so happens there's a useful tool to get that to happen, called project. So if we key in project, it asks for curves and points to project. So we have 2 curves. I'll select the 2 curves. And now it's asking for surfaces, polysurfaces, meshes, subdies. So let's go ahead and select our polysurface, right? And then hit enter. And you can see, because it was a solid, right, there's a top and a bottom surface. It projected the trail curve to both. For our purposes, only the top one is needed. So that's fine. I can just go in, explode this, and then just delete the line work that's not needed, right? And I want to show you that at the bottom here, where we already had a trail curve that was very close to the surface, it's actually not, right? I mean, it's close, but it's not in the same position. So you can choose just to keep this if it's just for reference, or if you really want to have a curve that is actually on the surface, you know, you can use that. But of course up here, right, this was our original trail curve floating down here. This is now the curve that's been projected onto the surface. So just so it's easier to read, if we go back to the shaded view, now you get a view of both of the curves, the trails as they were in the correct position on the site. Okay. Okay, well, I think that probably does it for this. Good luck, everyone.